All right, we are back. Welcome back, everybody. And the next presenter is Carrie Roberts. We're gonna go and have a hands-on workshop that I'm looking forward to it. Getting started with Atomic Red Team. And without any further ado, I pass it back to Carrie.
Hey, and welcome. I hear that this is streaming in multiple locations. I hope that a lot of people are on and can benefit by this introduction to the Atomic Red Team project. We've got some hands-on labs if you want to stay after and do those. I got a short link here for you if you want the slides, if you want to follow along. You can go to rb.gy/mkl158. And if you're in some of those channels, in the Discord channel where this conference is running and you don't mind sharing that link in those channels so the most people get that link as possible for the slides for Atomic Red Team, that would be great. My name is Carrie Roberts. I have a background in PC, mobile, and web app development. In 2010, I was a web app developer, and I didn't know anything about security, even though I had gotten my degree in computer science 4 years earlier. They didn't teach me anything about security. And my company had my web application tested to see if it's secure, and it came back with a bunch of red critical vulnerabilities all over it. It said this site is vulnerable to SQL injection and cross-site scripting everywhere, among some other things. But that's the first time I was introduced to those words, SQL injection and cross-site scripting. I didn't know what it was, but I read the report and realized what it was. And I was just shocked and humiliated that my application could be so easily and completely destroyed by anyone who wanted to do that as a hacker. And luckily it wasn't live yet. So we got those things taken care of before we went live. But it was a real career and life-changing moment because I realized I couldn't be a good web application developer if I didn't know anything about information security. So from that, after my initial discouragement, from that, I decided to embrace the idea of learning about information security. And I took some training from the SANS Institute, and it was very well done. Decided I want to go for a master's in information security from SANS. And so I finished that back in around 2015. I spent 3 years as a pen tester at Black Hills Information Security. I moved in 2017 to Walmart's red team, spent a couple of years there. And then the last 2 years I've been on the blue team. I wanted to round out my knowledge. I wanted to understand how the other side works, how the defense works, why things that we do on the red team work sometimes easily and why things don't, and what makes it hard, what kind of techniques are hard for blue teams to stop, what kinds are easy, what can be done to circumvent that, but also on the defense side, what can we do to block these offensive tactics. I am one of the maintainers for the Atomic Red Team project, and also have contributed a lot to the code for that project. And I often speak at conferences and have other open source tools you may have heard of, like the domain password audit tool and Slack Extract. Let's get right into it. The Atomic Red Team project is a library of scripted cyber attacks. So you may have heard of the MITRE ATT&CK framework, which defines tactics and techniques seen commonly used by adversaries. But it kind of falls short when it comes to, okay, I want to see if I can detect, or I want to try doing this technique. What do I need to do? You know, what button do I need to push? What command do I need to enter? And that's where the Atomic Red Team project really comes in. It's discrete commands. You can run this attack by running these 3 commands together. And then you can use that to learn about attacks. You can use that to do research, and you can use that to build your detections. This project was started originally by the Red Canary Company out of Colorado that does managed detection and response. But they've open sourced it, and there's over 150 contributors at this time, and perhaps some of you will become contributors after you learn about it. It's free and open source, community developed, so that's really cool. This what I'm covering here today in this 1 hour presentation, plus the 2 hours of lab, is really a subset of a larger class that I teach. It's a 4-day class, 4 hours a day, so 16 hours of class on attack emulation. You can see the schedule there. We cover MITRE ATT&CK and the attack navigator. We cover what we're going to cover today, and then another section on that. We cover Prelude Operator, which utilizes the Atomic Red Team library, another free project that is similar to Caldera, if you're familiar with Caldera. We cover Caldera and take you through the Caldera training so you can get certified as a Caldera operator. We cover the Vector Purple Team reporting tool, which students love to learn about that. That's also free. And then day 4, some smaller miscellaneous topics with some optional stuff for Scythe. And we make the Scythe part optional because it's not free. And some people just aren't interested because they know they won't be using it, but other people are interested to find out if they might like to use it in the future. But today you'll get a sample of that class. So I'm going to lecture for 1 hour and introduce you to Atomic Red Team. We're going to do some running of commands. And then immediately following, there'll be 2 hours of lab time that you can use, and you'll be given an IP address to connect to with remote desktop protocol client. And then if I can figure out what Discord channel everybody's on, I can answer questions there. Again, there's a link to the slides if you want to follow along. Yeah, so at the end, I'll tell you how to get assigned your IP address so you can connect. But those lab machines will shut down 2.5 hours after class is over, just automatically. So they'll just blink off, and then that'll be it. The lab time will be over, and it won't be offered later, except at future presentations like this, which I am doing another one of these exact things through Black Hills Information Security webcast in April. So there are other options. So just to make sure we're all on the same page quickly, I want to talk about the MITRE ATT&CK matrix, which is what we're looking at here. So it's a grid view of the tactics and techniques used by attackers with a lot of extra information about what groups use those tactics and techniques. So across the top, we have various tactics. For example, initial access is one tactic, and under initial access, there's multiple techniques. For example, one way to get an attacker to get initial access to a network is through phishing. So that would be one technique. Going down each column are the techniques. So under the credential access tactic, we have multiple techniques. So an attacker may be able to get access by brute forcing credentials, guessing passwords, sniffing the network. So those are various techniques. Each of these techniques has a technique number assigned. It's a 4-digit number. It starts with T. Sometimes it has a sub number like .001 there. T1003 is the technique, and the sub technique is .001. That's important because everything in Atomic Red Team is tied to the MITRE ATT&CK matrix by this technique number, and we'll see that when we demo. So a quick note on why it's valuable to emulate attacks. So I did talk about this a little bit, that if we use that library of scripted attacks, for one, we learn about attacks and get ideas for attacks that we could do if we're offensive information security professional, or about ways we could defend against. In addition, we could run those scripted cyber attacks in a test environment so that we could look at what telemetry they generate. And we could also validate that in our environment, everything's working. There's a lot of pieces that have to work together in order for the whole detection and response system to be working. And that's something you can validate with these scripted attacks. So maybe if you run certain attacks every week, and every week you make sure that the events get captured on the endpoint, they get forwarded to the central collection agency, the alert logic runs, it really alerts to an analyst, and an analyst really raises an incident to the incident response team. And then you feel confident that any detections you have developed are still working week to week, because there's a lot of things in that chain that can break. And you can also use these scripted attacks to tune your configurations. For example, if you have a product running like sysmon for Windows, you need to configure that to hopefully record the most important events that help you find and respond to attacks, but ignore everything else, because it can record just way too much information for you to realistically hang on to and search through. So it takes some skill to tune those configs to keep the important things, but how do you decide what's important to identify attacks? If you're running these scripted cyber attacks, you've got that information that says, if I want to know that this thing happened, I need to hang on to this piece of information from each of my systems. And you can also use it to compare security products and see which products detect which of the scripted attacks. So a quick example of one scripted cyber attack or one atomic test. In Atomic Red Team, we refer to each scripted cyber attack as an atomic. So you might hear me call it an atomic test or an atomic. So here's an example of an atomic. It's using bits admin to download and then execute. So here we have 4 simple commands. It downloads a file called bits.bat, but then it uses bits admin to actually start up an executable. In this case, it's just Notepad. But imagine that that's some malware that an attacker is trying to start up. And one reason why an attacker might use bits admin to execute their executable is because the parent process when bits admin starts an executable is svchost.exe. So that looks like something more likely to supposed to be happening in an environment. So it may go unnoticed by a blue team if SVC host is starting something up versus just cmd.exe. And so this is an example of an atomic test that probably no security product is configured to alert on or block, because it really is doing exactly what Microsoft designed it to do. But at the same time, it's not something commonly used. So I work in a very large environment, and I know that it just isn't common to see bits admin launching executables. So with this knowledge, we could fine tune our own custom detections to say, hey, if anybody does this sort of thing, even though I know that it isn't necessarily inherently bad, we want to know because it just doesn't happen that much. Or we could put on some allow list those few systems or people that we know do this kind of thing, and then just be alerted to anything else outside of the norm. And that's really where the beauty comes in with the scripted cyber attacks, is especially these things that these atomic or scripted cyber attacks that probably will never alert by default out of any system, but are rare enough that you could probably build your own custom detection and keep an eye on it. Okay, so real quick about Atomic Red Team. One thing I want to make sure everybody keeps distinguished in their mind is Atomic Red Team is really 2 pieces. There's Atomic Red Team, which is the library of scripted attacks. And then there's various execution frameworks. So an execution framework is something that can read that library and run the commands according to what's specified. So we'll see in the scripted attack, it'll say run these commands in command prompt, run these commands in PowerShell with or without admin. Before you run these commands, make sure you get this set and that set to prepare for it. And after you run it, do these commands to clean up and reset so that you can run it again. So there's a lot of things in that scripted library of attacks that it's handy to have an execution framework that just basically follows the recipe in the scripted library according as it's specified. So there's a variety of execution frameworks. So on that first slide, I mentioned Prelude Operator. So Prelude Operator is a free tool that you can use to execute Atomic Red Team tests. And another example is Caldera. Caldera can import the Atomic Red Team tests and execute them. Red Canary also provides I would call it simplified execution framework. It's a PowerShell script that can also execute these tests according to specification. And that's what we'll be using today, and that you'll be using in your labs. So it's valuable because it's straightforward and it works on the system that you have Atomic Red Team installed, or a remote system, but it requires PowerShell. So sometimes you might want to look at other options like Prelude or Caldera to execute tests if for whatever reason PowerShell isn't a good option for you. Okay, so this is where we're going to back out of this presentation. If you're following along in the slides, you'll just see that the slides are kind of an outline for what I want to remember to demo, but we're going to be demoing it. So what I have here that I'm sharing is actually the lab machine. So if you decide to stay afterwards and do the labs, you'll be RDPing to an IP, and on that system, it's going to look like you see here. So you have the Chrome browser, which you're going to want to use because it has all the bookmarks for the class. And then, so I have this open, and in the bookmark bar of Chrome is this labs link, which I have open here. So here's the labs, the 7 labs that you can do either in the lab environment, or you can do them on your own test VM somewhere. But I don't recommend that you download and install Atomic Red Team over a corporate network because it'll set off some flags. So if you're going to play with this outside of this lab environment, do it on your own VM over a network that you have permission or own or whatever that won't get you in trouble. And you definitely want to start out playing with this on a disposable system until you get comfortable with certain tests that you may then run elsewhere. So here within this lab document, there are links to the slides. At the top, there's the 7 labs. I've already installed Atomic Red Team and imported the module for this demonstration just so that I can keep it within an hour, but you have 2 labs here to do that. If you're going to run these labs at another time, go ahead and download all these documents as well. So that, well, or just grab the link so that you have access to those later. Okay. So before we get to there, first, we're going to go to the Atomic Red Team GitHub repository. So Atomic Red Team itself is a project that lives in GitHub. GitHub is a place where it's easy and convenient to collaboratively develop code type projects, which is what this is. So this is why this project is in GitHub, and you see it under the Red Canary Co. You see there's over 153 contributors. You see a lot of stuff here, which can be overwhelming, but by the time we're done, you should feel better about this. The first thing, let me zoom in a little here. The first thing I want to show is this wiki. So I'm definitely biased about this wiki because I wrote it, but I put a lot of stuff in here that I get asked a lot by newcomers to the project to try to help get people started. So here you see it starts out with the philosophy. It talks about executing tests, and it answers frequently asked questions. It's also got a section on contributing. So that's a big section. If you want to contribute back to this project, it'll walk you through how to do that. There's even demo videos. And then the main Atomic Red Team thing over here, it walks you through the whole GitHub repository and the attack navigator, which I'm going to walk you through the repository right now. So that's the wiki. So remember that. Go to the Atomic Red Team project and then the wiki. Okay, so if we go back, we're looking at all this stuff. So there's a lot of stuff in here that really just kind of supports the project that you don't need to concern yourself with. The thing that you want to look at within all these files is this atomics folder, because it contains the library of scripted attacks. So we go into this project, we go into atomics. And now, with the exception of the first folder, everything has a technique, is a folder with a technique number. So we remember seeing T1003.001 with 001 being the sub technique defined by MITRE attack. And so here we have a folder for every MITRE technique that has at least one atomic or scripted cyber attack in it. So you see there's a lot here. In fact, if you go into this indexes folder, you can see how many there are atomic tests by operating system or just all together. For example, if we could look at how many tests are there for Windows in the Atomic Red Team project. And so here we could look through all the tests for Windows. So the indexes just have indexes in a variety of formats. They have CSV, Markdown, YAML indexes, and of particular interest is this attack navigator layers. They describe the index in a JSON format that can be imported onto the attack navigator. And if you haven't seen that, it's a great way to visualize coverage of like detections or attacks on the MITRE attack matrix itself. So within this lab, I've also got under MITRE attack, the MITRE attack navigator, but I've also got a link that says MITRE attack navigator art, atomic red team art coverage. So if we load that, it's actually, it's actually going to show us let's maximize this. It's actually going to show us a red cell for every technique that has at least one atomic or scripted attack written for it. So here we see, just at a glance, we get a feeling for how well the Atomic Red Team library of scripted attacks covers the entire attack space defined by MITRE. And everywhere you see these little gray bars is actually, you can expand that to see the sub-techniques. So actually, under this technique, account manipulation, there's 4 sub-techniques, and there's an atomic test under SSH authorized keys, but not under the other 3. So if you want to go through and see in detail what's covered, then you can do that. So here, 2 out of 3 of this, or actually 4 out of the 5 sub-techniques are covered here. So that's at a glance, you can quickly see to some level, the coverage level of the Atomic Red Team library of scripted attacks. And these layers are automatically updated. So every time you load this URL, it'll be updated. And if I add a test today for additional cloud credentials, and you load this up after I contribute that test, that'll turn red automatically and you'll see that. So this is always up to date. So that's the indexes. So back to this. Let's look into one of these folders. Let's go into T1016. So inside of one of these technique folders, you'll always find at least these 2 files, a YAML file and a Markdown file. These files represent the same information essentially, but the YAML file is very machine readable. That's what the execution frameworks use to read. But let's load this up. It's really not very fun for a human to look at. Like, you can't quickly understand this, even though the information is there and it's very structured. It's just not fun to look at. So when you're just browsing around to learn about these atomics, it's better to look at this Markdown file. This Markdown is automatically generated from the YAML file when new tests are contributed to the project. So it's always up to date. So here's the Markdown version. So we see it's got nice lists and formatting for easy for us to read. So we see that technique T1016 is the technique of system network configuration discovery. And then in the Markdown file, it actually copies in the description from MITRE attack right here. So if you went to their website to learn about what is system network configuration discovery, you would see this paragraph. So it's copied right in, and it's just here for convenience, so you don't have to pop back and forth. And then it lists out the atomic test. So under this technique, there are 7 atomics, scripted library attacks. So let's look at the first one. We have a description of it. It says it's for Windows. It says you should run it from the command prompt. And what should you run? You should run this. So in its most basic incantation, you could use the Atomic Red Team library to just read about attacks. So you could come here and you say, oh, here's the kind of commands you might see if somebody runs this attack, and they would run it from PowerShell or command prompt or shell. So these atomic tests cover Linux, Mac, and Windows, and you can look in those indexes to see how well the coverage is, or click on those links for the attack navigator to see the coverage. There's hundreds of tests for all 3 of those OSs, so it is multi-OS for the test. But so at a minimum, you could read through this and learn and get ideas for whatever kind of projects you have related to information security. But you could also execute these. So here in our environment, one way we could execute this is we could literally copy this, and we could go over to the command prompt like it told us to, and we could paste these things in and run them. And then we may, depending on our use case, we may go look at what telemetry was gathered when those commands were executed and see if there's some sort of event ID we could trigger on to know that this happened, if we wanted to write a detection for that. But again, not everybody's use case is the same. So that's manual execution. So that's cool. You just have to look at whether it's to be run in the command prompt. If it has to be from an elevated command prompt, it'll say run as admin next to it. And then you have these commands here that you could copy and paste in. Here's another test. It's just a one-liner that you run from the command prompt. Here's this third test is intended for Mac OS and Linux. So you run that in shell. So this doesn't apply. These commands wouldn't work on Windows. Let's look down at a more complicated test. So here we have list open egress ports. So what this does is it runs a little script to reach out from an internal network to the internet and find out which ports it can access the external internet from. So it's like, can I get out of this network on port 25? Can I get out of this network on 26, 27, 28? And so all those ports, if an attacker determines are open, they can use any of those ports that they find open outbound to exfiltrate information. So this is something an attacker might do to determine what their options are for getting out of the network. And we notice some different things. There's a lot more information in this test. We've got an input table. So we've got basically input variables that when you execute this, you could use the default values here for these input variables, or you could specify your own. So now these commands are customizable by specifying your own variables. So we might, instead of when we run this test, maybe we don't want to write the list of open ports to the user's desktop. We want to write them somewhere else for whatever reason. Or we don't want to scan the top 128 ports. We have specific ports we want to scan. So we could specify a different file of ports to scan. And so then we look at the attack commands, and it says we should run this with PowerShell. So if we were to copy and paste this like we did for the last command into PowerShell, we'd get errors because this right here is not valid PowerShell. What this is a reference to these variables. So you see port file right here, and you see port file right here. So these scripted attacks are using these variables. So before you run this, you should substitute the default value here. You should substitute this string in right here. And then you should substitute the output file, you should substitute that in here. So now if we wanted to run this manually, it'd be a little of a pain in the neck because we'd have to copy the attack commands out, paste it into Notepad, grab all these default values or our own custom values if we wanted, paste them in, and then run them. So now we're starting to see why an execution framework might be handy, because we could avoid manual copy and pasting and replacing of text because it would do it for us. And we could also script execution, for example, if we wanted to run these same tests every week to validate our detections. And this test also has cleanup commands. So it says after you run the test, you might want to run this cleanup command, which gets rid of that port file from the desktop. That's not too critical to have that port file laying around, but sometimes these atomic tests do other things that need to be reset on the system, like the atomic itself might set a registry key to a less secure value, and then the cleanup would set it back to a more secure value. So the cleanups are especially important in that example. In addition, this test has some dependencies. And in this case, it has one dependency that says, in order to run these commands, you need to have the port file that was specified, which is that top 128.txt, or the port file that you specify. And then it has some commands here that you could run to check to see, do I have the port file? Yes or no. If I don't, then I could use this to get one. Like this downloads that port file from whatever URL is there, which is Red Canary at this point, but you could have your own port file hosted somewhere, and you could use the execution framework to download your prerequisite file here. So definitely we're quickly seeing how an execution framework would come in handy. Let's jump over to the execution framework. So here we're in Red Canary Co. Atomic Red Team. And just as a reminder, this is where we went into the atomics folder and we see all the techniques that have atomic tests written. Inside of those, we have those files that describe each test, which is a series of a small number of commands that execute one piece of an attack. Now we're going to back up to the Red Canary repository and go over to the one called Invoke Atomic Red Team. So this is the execution framework. It's the PowerShell script that can read those technique files, those YAML and Markdown files, and execute it according to spec so that we don't have to manually copy and paste and replace input arguments. Again, in this repository, there's a very nice wiki. And over on the side, it tells you how to install this execution framework, how to import the module so the command to execute atomic tests is always available to you, how to list atomic tests, on and on and on. All of this stuff, most of this stuff I'm demonstrating here, so I won't read it off to you, but it's all there for your future reference. Let's see. Yeah, so that's basically what you need to know about Invoke Atomic Red Team Wiki. Now we're just going to go demonstrate this project. So I mentioned it's a PowerShell script. So once you install Atomic Red Team, which again, I've already done, but in the labs you can do it, or if you take the lab documents in your own environment. Man, I keep typing the wrong thing. Oh my gosh, it's a bad day. Okay. You'll have to install it first and import the module, but once you do that, you'll be able to use the invoke atomic test function. So invoke atomic test in general, it works like this. You give it a technique number. So we were looking at T1016, and then you can have it do things like execute all of those atomic tests or just a subset of them that fall under T1016. Or for starters, we could ask it to show the brief details. So that just means show us the tests, the atomic tests that are under this technique. And let's go back to the Atomic Red Team repository and have this open on the side. Atomic Red Team atomics. And we're on T1016, so I just want to cross-reference this as we're playing with this. If we go into the T1016 Markdown, we see 7 tests. And we see that lining up pretty good over here. So we have tests 1 through 7. We have system network configure, list Windows firewall rules, same thing here. But we see that test number 3 is missing, test number 3. If you remember that test number 3 was that test that applied to macOS and Linux. So the execution framework knows that it's running on Windows, and it's only showing us what applies to Windows. So that's why test 3 is not in the list here. Once we know what tests we're interested in doing more with, we can specify a test number, for example, test number 1. And we could say show details without the brief on the end. And that gives us kind of a command line layout of what you see here on the Markdown file. You see the test name, a description, this description, You see that you're supposed to run it on the command prompt like it says here. Here's the commands that you run, which was same as here. So what we did before is we copied these into the command prompt and ran them, but with the execution framework, we can just say, we can get rid of the show details, and we can just say run that. And so now what it did is in the background, it started up a command prompt. It entered those commands, and then it showed us the output at the end over here in PowerShell, even though those commands didn't execute in PowerShell. So it followed that, which doesn't save us a ton in this example. But let's go look at the more complicated test, which was test number 5. That's the ports, I think. Yeah. So down here, test number 5 that we were looking at, list open egress ports. This is the one that had 3 variables, and you can see the variables listed here in red: output file, port file, a port file URL. So it highlights those for you. And we see the commands. So here we see ports equals get content port file. We see the same thing right here. Whoops. So we see that command here. But in addition to having the command like verbatim, as you see it here, you can also scroll down and you can see the command with the inputs already put in. So here, this port file has already been replaced with the default value for port file, which is our atomics folder technique, or top 128. So that's already filled in. So at this point, we could just copy these commands because the variables are all filled in, and paste it in PowerShell and run them. But it's easy to just ask PowerShell to do that for us. And we could also say, also run the cleanup commands or whatever. So let's move this over here so we can actually watch this run. So if we, let's clear this screen. So if we take off the show details, we're going to be executing test number 5, the open egress ports. We'll see a file appear here on the desktop afterwards. So from this system, everything's open outbound. So no controls going outbound from this lab network. We can see the same information was written out to the openports.txt. And then at the end, we mentioned there's cleanup commands. In this case, what it does is it just deletes this output file that got written to the desktop. So that we can use the execution framework again to run those cleanup commands. So we just tack on a cleanup flag like that. And then that disappears and our system's reset. That was a really simple example of a cleanup, but you can imagine if services were stopped that need restarted, or registry keys were changed, or other crazy changes were made to your startup folders, the cleanup could reset all of that for you. And with this execution framework, you can now script the execution. So if you do want to run multiple tests every day, you can do that with a simple script to do that, and instead of somebody manually copying and pasting. So let's see, what do I want to show now? Let's show a way that we can specify our own input arguments. So if we want to run test 5, but we don't want to use the top 128 ports, we have a different file we want to use, we can add in this flag here called prompt for input args. And this is all on that wiki, that execution framework wiki, to all these examples. So we could say prompt for input args. Now it says, let's maximize this. It says, okay, what do you want to use for your port file? It says, I'm going to use, well, actually for the URL to download it from if you don't have it. So that's fine. We don't want to change that. So we just push enter. And it says, how about for the output file? So maybe we let's change this one because that's easy to demo. Maybe we say we don't want it there, we want it here. And then we'll go ahead and do top ports because I don't want to have to make another one for the demo. So if we, so now we have a file called here. So that's, you know, not an important distinction, but it does show you how you can change the input arguments. There's also a way, instead of being prompted, because I keep bringing up the fact that execution frameworks let you execute tests unattended, you can also specify your input args with this input args. Instead of prompt for input args, it's just input args. And here you pass it a hash table. I'm just using a variable here called hash table, but before you run this command, you would specify in this variable hash table all your input arguments. So you would say for port file, use this, for URL, use this. Anything you don't specify specifically, we'll use the default values, but that's how you can script using custom parameters without having to be prompted manually. Okay, so let's take a look at a different test. We're gonna look at T1485. And just for starters, we'll get an idea of what tests are in there. So we'll show details brief. There's only one test. It's overwrite file with sysinternals sdelete. So before we specified a test number, if you don't specify a test number, it runs all the tests under that technique. So in the last example, that would be 6 tests because one of them was Mac OS Linux. But if we would have just said invoke atomic test T1016, it would have ran 6 tests back to back. In this case, it's all the same because there's only one test. We could invoke the tests like this. There is a special technique number that you can enter, which is all, and it would run all the tests, but it will leave your system pretty messed up. So I don't recommend running all unless you're like in this lab environment and you don't care and you just want to see some blow up. The thing, you know, for one thing, it changes so much and there's interdependencies that it basically does mess up your system permanently. But the other reason is you're just blowing up everything that in the end, you can't, it's not really valuable to you because there is so much on the system that changed and so much telemetry that you can't even wrap your mind about what actually just happened and what should I be seeing. It's just like, it literally blows up the whole thing and you're like, okay, now what? But anyways, one useful thing to do with this is if you actually show details brief, it'll list all the tests that apply to your current operating system. So we can let this run for a second and we can quickly see, wow, there's a lot of things that I could choose from. So that's kind of cool. I'm going to stop it. So back to T1485, and these things actually aren't case sensitive, so I'll do that just to show that. But I don't need to specify a test number because there's only one. Let's go ahead and try to run that. And it says sdelete is not recognized as a name of a command that, so basically it can't run sdelete because sdelete isn't on the system. Sdelete doesn't come on Windows by default. So if we go back where it's easier to read about this test, if we go back to the atomics folder, and look at this test, we see there's some input arguments where you can specify where your sdelete executable is and what file that you want to delete. So there actually are some prerequisites here, some dependencies that says in order to successfully run this scripted cyber attack, you first need to have the secure delete tool from sysinternals on disk wherever this variable specifies. So if you don't change the default, then it should be in the temp directory sdelete. And then it's got some commands to check that, but the execution framework can use these commands to our advantage. So we can use the execution framework and ask it to check our prerequisites. And now it reports that in red, you don't meet the prereqs for this test. So if you run it, it's going to fail for sure. And the reason why you don't meet it is because the secure delete tool from sysinternals isn't on your system. So now we can, let's clear this again. Now we could say get prereqs. Like, okay, I don't have sdelete, but I want it. So get it for me, please. So we could say get prereqs. Okay, now it says attempting to satisfy this prereq to get sdelete, and got it. So now if we were to check prereqs, it says everything's good. You can run the test. So now we just get rid of that check prereqs flag and run the test. And if you don't specify a file to delete, it creates a temporary one here in the temp directory and deletes it. So it says sdelete just deleted this 1485.txt successfully. Boom, you just use sdelete to delete something. So then if you're interested in seeing what kind of detectable actions can be found after doing that, you can do that at this time. So an adversary, an attacker, will often use secure delete to overwrite their file in a way that forensics can't figure out what they've done. So it's a way of covering their tracks. I think that's what I wanted to demo live. So we'll go back to the slides. And how are we doing on time? 15 minutes left, so we're doing good. Go. Okay, so each time you run an atomic test, not the cleanup or the prereqs or the show details, but actually execute the attack.
Carrie, something happened to your audio. I don't know if you disconnected your microphone.
Uh-oh. Still not hearing me?
No, I cannot hear you.
Testing. Okay, how about now? No. Oh, shoot.
And if you can hear me, it happens right after you went to the slides.
Can you hear me?
There we go. We can hear you now.
Okay. It's probably not going to be as good of audio since but is it workable?
At least I can hear you from my side, yes.
Okay. I might have to speak up too. Okay, that's a bummer. That's weird. Okay, so back. Do you happen to know about? Oh, it's when I went back to the slides, so not too long ago.
Yeah, it's right after you switch to the slides.
Okay. So when you execute an atomic test, a record of that is kept on the system. Only when you execute the actual cyber attack part, so the attack commands, not when you do cleanups or list tests or get prerequisites, nothing's recorded there. But when you actually execute the atomic test, file is written in CSV format to a default location, but you can also specify with the execution framework where you want this written. But it looks like this. It's got the execution time, the technique number, the test name, the host name, and basically the time, the system that it was run. So you can use that to correlate with your detections that says, hey, I ran this attack at this time on this system. Did we have an alert come up for that? And so all of this can, there's a lot of information here. There's over 650 tests just for Windows. Sometimes it can be overwhelming to try and get started, and it isn't super easy, like, to build a whole program around this. Like, you wish that you could say, oh, well, I'll just run all the tests and then I'll see what got detected. Well, it sounds easy, but actually making that happen, especially in any sort of automated fashion, is still a lot of work. So you've got to get your test system set up. You have to somehow tie them into maybe your production detections. And then you have to correlate this CSV log of what you actually ran to alerts from a lot of different systems and say definitively this alert was definitely catching this atomic test. So as a hint to get started, in the slide here, I have a link to at least a smaller subset of Windows atomic tests that you could start with. And I handpicked those just based on kind of some criteria, like they're less likely to just outright not work because like Windows Defender would block them and not even let them run, or maybe just because they're particularly cool. Maybe they're easier to understand. They take less setup. So they'd be highly valuable if you were to detect them. Like these things like bit-to-admin that aren't going to be blocked out of the box, but really are uncommonly used that you can realistically do detection about. So I do give some suggestions on a smaller list there that you could use to get started with testing. And some quick notes about how you might set up your test environment. So as I mentioned, first you want to start testing in like this lab environment I have, or on your own VM outside of your corporate network or something, somewhere where the system is resettable if you mess it up. And just get comfortable with atomic red team and the execution framework and the various atomics, because ultimately it comes down to be your responsibility to decide if a certain atomic test is safe enough to run in your environment. So as maintainers of atomic red team, we try to review things and make sure nothing malicious gets into the repository, but it is community developed. It is possible that something could be in there that's undesirable to run on your systems. And so you need to get comfortable with what each test does before you run it anywhere that may impact your system. So with that being said, after you get comfortable with the atomic red team, you may do something like get a golden image from your organization. Golden image being the type of thing that gets handed to a new employee. So it's got all the same programs, all the same AV configuration on it, firewall rules that your end users get. You could install Atomic Red Team on there and the execution framework and run the tests against yourself. So Atomic Red Team, I mentioned, you can run it on the local system where you install the Atomic Red Team, or you can run it against a remote system. So this blue arrow here is indicating you install Atomic on this system, Atomic Red Team, and you run the test against that system too. So it's all on one system. And in this scenario, this represents AV. You have your AV installed, but maybe you don't. So I actually recommend, in my opinion, I like the saying that prevention is ideal, but detection is a must. So in my experience as a red teamer and a pen tester, there's always a way to get around the blocking controls that are on an endpoint. So as a defender, I want to always make sure that if this thing is allowed to execute, maybe they just tweak it a little bit. Oftentimes, to get something to get past AV, you just can remove a comment that says power. I just want blank on the credentials. So I want to say power swipe, but Mimikatz. Literally remove the word Mimikatz from the comments of the executable now runs or something. Oftentimes, it's something almost that simple. So, anyways, instead of me wanting to spend my time finding all these ways or little ways around AV blocking controls, I'd rather just turn the blocking controls off and say, okay, if this eventually does end up running somehow, would I know as a defender that it ran? So whether you set up your environment like that or not is up to you. It's actually valuable to run it both ways. Let's run it and see what just wouldn't run. But let's also run it and say if something ran that we thought we would block, but it ends up running somehow, would we not? And in this case, we ship off our telemetry to our production central collection of telemetry. So maybe where we build our alerts off of. So this machine, it is a golden image, but it isn't necessarily on the corporate network, but it reports to the same production alerting system. And in that way, you can verify that your production detections are working. Another way you might set it up is you could install Atomic Red Team on one computer that may not even be the domain join, may not even be Windows. And then you could execute Atomic Test with the invoke Atomic Test execution framework against a remote system. And in this case, the only thing that runs on the remote is the one or two or however many Atomic Tests that you want to run. So when you install Atomic Red Team, it downloads all of those attack commands and a bunch of supporting payloads, so executables and DLLs that AV doesn't like. And it's going to set off all sorts of alerts. Plus, you have to install the execution framework. The execution framework requires the PowerShell YAML module, which isn't on Windows by default. So when you install Atomic Red Team, you actually change that system a fair amount because you're installing all this stuff. So if you want to have a very light touch on your system you're actually testing, you can install it on one machine and then you just execute tests through a PowerShell remoting system or a session. So as long as you can enable PowerShell remoting between the two systems, you could do it this way and have a much lighter touch on your endpoint. And this PowerShell remoting is how the Red Canary and Boca Atomic Red Team project does remote testing. But the other tools like Prelude Operator and Caldera, they do remote testing through a command and control channel. So you don't have to have PowerShell remoting enabled as long as you can establish a C2 connection between the remote and where you want to run the test from. So in that scenario, you might have your golden image with or without blocking controls turned on. You're executing tests from this other system that can be completely independent, and you're not worried about the fact that you have a lot of similarity malware on. In any case, you still report to production log systems. Got some notes here for how you might set up your own lab. You can download a free virtual machine from Microsoft. If you want a domain join lab with multiple computers, there's two options to automatically deploy that, free options. which is Detection Lab and Splunk. You click that link and it'll take you to those ideas. I mentioned the wiki has a whole section on contributing, so if you're wondering about contributing, please do that. So as a wrap up, we've got this great library of scripted attacks. We can execute that with any number of execution frameworks, including Caldera, Prelude, the PowerShell script itself, Scythe, all import this library of scripted attacks. There's a great Slack workspace with over 25 people actively talking about not just the Tomcat team, but attack emulation in general. And it's a helpful, supportive community. It's great to join. There's a link for how to join here. If you want to learn more about that 16-hour class, you can go to the Wild West Hack and Plus training schedule, where you can learn about it and sign up. And just remember, when you, I'm about to tell you how to get your lab IP. But once you RDP to that system, you're going to start up Google Chrome. You're going to click on the labs link. From the labs link, you'll have access to the slides. You'll have access to the 7 lab walkthroughs and some more information about setting up your own lab and joining the Atomic Red Team SciWorks. So let me show you one of those walkthroughs real quick. So for example, here's one of the walkthroughs. So it goes a little bit over what I went in the slides. It tells you about the repository and then tells you how to install it. So these are how the walkthroughs go. There's a lot of explanation. Be forewarned that when you walk through this, you're actually going to get AV alerts going off and errors. And that was on purpose because I want you to see that and then learn what you need to do to get around that. So don't panic if you see that the installation failed. Just keep reading and it'll talk about why it failed and what you have to do to get around it. But I wanted it to be very realistic because you'll experience the same thing. Okay, so now how to access the labs. I have no idea how many people are interested in running the labs. I've got 300 IPs available that I could quickly upload. I can deploy some more. So to get a lab IP assigned, you're going to go to, let me type this word. You're going to go to control panel. .dch1.online. Okay, so let's go there. Okay, so it's very simple form. You go there and you click get IP. I haven't uploaded any IPs there yet, but as soon as I end this, I'm going to upload at least 50, and then depending on how fast those go, I've got several more I can upload. If you run this get IP before the IP addresses are in there or if everything's used, you'll get this message that all of the IPs have been assigned. Please check back in 5 minutes. So give me about 5 minutes, I'll upload the first set of IPs. But please only ask for one. So as soon as you click get IP and actually get one, it marks that IP as used and doesn't give it to anybody else. So that if we have somebody go in here and get IP, get IP, get IP 500 times, there'll be no IPs for anyone else. So do that until you get one, and then hang on to that one that you get and use that for the labs. Again, if you're in some channel somewhere where there's actually live chat going on, or if Omar, you have a place to put that, if you can put the link to the slides and also how to get your IP there.
Absolutely, I already did. Thank you.
That'll be great. Awesome. And then if you want to send me a message to help me get linked up with the channels where people are at, I can be available during these 2 hours to answer questions. I actually didn't take any questions yet. Are there questions, Omar?
There are no questions. I'm actually monitoring both Twitch and YouTube and Discord as well. There are currently not questions that I actually have seen. However, I did see, a couple of people just saying, hey, I'm going to try to actually get the IP address right now. It wasn't working. So you're working on spinning up the VMs.
Yeah, give me just 5 minutes as soon as I close this down, and there'll be IPs there. If they run out, just within about 5 minutes, I'll load some more. I'll keep loading them up as long as people are using it, within reason. So just hang in there.
Perfect.
Do we want to close the stream?
All right. So first of all, thank you so much, Carrie. We really, really appreciate your time today. Thank you for your, supporting always the Red Team Village and the security community. And a quick reminder to everybody, please join the conversation via Discord. As we mentioned, the Discord information is on our website. It should be in the link below, whether you're on Twitch